All right. Chapter 10, section 2, talking about the area of triangles and a bunch of different quadrilaterals that we've learned throughout the year. And we'll also talk a little bit about perimeter. Okay, so first off, just a quick review of what area and perimeter are. So the perimeter is just the distance around a figure. So in this case, we're looking at a square, 3 units by 3 units. There's 4 sides. Each one is 3 units long. So our perimeter would be 12 units, 3 plus 3 plus 3 plus 3. That's just a distance. Whereas the area is the number of square units that the figure covers. So in this case, you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. Sometimes we write this units squared. And another way we can find this for a square is to multiply the 3 by 3 to see how many square units we have. And so it's really important that you always show the units in your answer. In this case, we don't know what the units are, but we're just going to write it as units or units squared. A lot of times they'll be in inches or feet or meters squared or square miles. And if you don't include a unit, your answer just doesn't have any meaning, because 32 feet versus 32 millimeters versus 32 square miles all have different meanings and values. And so if you don't include your units, really all the work you've done is pointless. So make sure you always include your units. For perimeter and distance, that's just going to be a regular unit without any square or anything like that. And area is always going to be that units squared, written to the second power. So we'll see some examples here, but before we get to that, we just need to go over all of the formulas for these different shapes we've learned about throughout the year. So for example, a square, as you guys know, a square has 4 sides that are all equal. We're just going to call that S. And the area formula is just side squared. So we multiply side times itself and find the perimeter. It's just 4S, S plus S plus S plus S. For a rectangle, we have a length and a width. So the area is just length times width, side times side. And then the perimeter would be length plus width plus length plus width. So 2L plus 2W. You're probably familiar with some of these already. All right, parallelogram. A parallelogram is going to have a base and a height. So this height needs to be a perpendicular segment connecting the top of the parallelogram to the bottom, forming a right angle. The area is just the base times the height. The perimeter would be adding all the sides together. We don't have labels for those, but it would just be adding them all together. And we're not going to have perimeter formulas for every shape because you just need to figure out each side and add them up. For a triangle, we also have a base and a height. Again, that height is connecting the top of the triangle all the way down to the base, meeting at a right angle. You'll see sometimes that height is actually a side of the triangle, and it's a right triangle. That height will be a side of the triangle. Sometimes it will not be. So these are 2 different figures showing the height and the base of a triangle. And for a triangle, it's 1/2 the base times the height. And again, you might be familiar with these already, but if you're not, or even if you are, probably just write them down for reference for later. A couple more shapes, and these ones you might be a little less familiar with. A trapezoid. Again, we've got a height connecting the 2 bases, top to the bottom, but this time our 2 bases are going to be different for a trapezoid. We got base 1 and base 2. And so our area formula for this is 1/2 times the height times the bases added together. And then our formulas for the rhombus and for the kite are the same. It involves drawing in those diagonals. And you might recall that the diagonals of rhombuses, which we have a rhombus right here, and kites, which we have right here, are always perpendicular. And so we basically just have 4 triangles in each of these cases. Triangle, 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 and here triangle, 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 triangle. So that ends up giving us a formula of 1/2 diagonal times diagonal. You'll notice that looks kind of similar to the triangle formula, and the reason why is because we calculate it the same way. We just have 4 triangles that we are finding the area of.